Okay, so what we're going to be looking at now is we're just going to touch on something that I didn't cover in the previous section about ionic bonding. However, you should know this anyway based on your information from C1, and that is to do with conduction of electricity in ionic bonding. Okay, and the idea here is that, number one, just to recap, an ionic bond is between a metal plus a non-metal, so that's just a recap, and it's caused by a reaction between, remember, the metals are cations, plus your non-metal will be an anion, which means it'll have a negative charge, and these two will join together or react together to form a neutral compound. Okay, so just remember that, guys. So the question is, well, if we have Na, which is going to have a plus charge plus Cl minus, right, it's going to make NaCl. Now in this form, number one, it's neutral, and number two, it's a solid. And when ionic compounds are solid, they do not conduct electricity. Okay, they do not conduct electricity. Now you need to do one of two things in order to make them conduct electricity. You need to do one or two things. You need to either, number one, put it in water so that it becomes a solution. Guys, by the way, this shortcut here is a shortcut for writing TION. Okay, so solution, and basically that will make these charged particles free, which means that you can conduct electricity. The second thing you can do is to make it molten, and once again that will allow free moving ions, and as a result you're going to have electricity being able to flow. Right, so in the solid state, there's no it can't conduct electricity. To make it conduct electricity, you make it into a solution by mixing it with water, or you make it molten, and that will allow you to conduct electricity. So now we're going to be moving on, and we're going to be looking at solubility. Okay, so solubility is whether something can dissolve in water or not. So if something is soluble, that means it can dissolve in water. Right, and a basic example of that is you put your sugar in your tea and the sugar dissolves. Right, so we can say that the sugar is soluble in this case. An insoluble thing is something that does not dissolve. So let's say you got some sand and you try and dissolve that in some water. It's not going to dissolve, and so that we say is insoluble. Right, now there are some things that you're just gonna have to learn. Okay, so I'm just gonna make the opacity of this opaque, and what I'm gonna say to you guys is just pause the video and make a note of this. Okay, so these are things that are typically soluble on this side, so these are soluble stuff, and on this side these are insoluble stuff. So just pause the video, make a note. Okay, but I'm gonna move on now. You're just gonna have to remember them, unfortunately. Okay, no two ways about that. So what we're gonna do now is but there's something important that you need to know, because in the exam this word will give you a hint. Okay, so if in the text of the question they use the word a precipitate is formed, precipitate is formed, right, then this is your keyword. This is the word that tells you that the thing they're talking about is insoluble. And so if it's insoluble, that means it does not dissolve. And so something that forms a precipitate will be a solid. Okay, so it's going to be a solid. So this is the keyword you need to look out for, and then they'll basically ask you which one is the solid, while it's always the precipitate that is a solid. Okay, So a precipitate reaction is lead nitrate plus potassium iodide. Now guys, for foundation they will kind of give you this in the text, and you will have to kind of just miss in the filling words or something like that. That's how it's usually done. Makes lead iodide, so this lead bit, so let me just show you, this bit will swap places and join with this one to make your lead iodide. There's lead iodide plus if we go here, these two will join together, potassium and nitrate plus potassium nitrate. Now in your exam they will tell you, for example, that the precipitate formed is lead iodide, so this is going to be your solid object. Now these two, what you got to remember is these two are soluble in water, and so precipitate is formed when two soluble things react to form precipitate. Okay, and this one is the precipitate, it's the solid, it cannot dissolve, so it becomes a solid, and you can see it actually forms a yellow precipitate. So this will form a yellow precipitate. Now I've shown this to my class, this reaction, Precipitate, and it's quite cool, it's quite a nice reaction. So majority of teachers will have shown you that. It's quite simple to do, and it's really beautiful. Form this really nice yellow solid from two clear solutions, which is just amazing. So the formula for this, and guys with foundation they'll kind of get you to fill in the gaps or balance equations. Okay, it's PbNO3, and we've got two lots of those, plus your potassium iodide. It's gonna make you your lead iodide plus your potassium nitrate. So to balance this, we're going to balance the oxygens first. So I'm going to put, so I've got 6 here, and so I need 6 on this side, so I'm going to put a 2 in front of there. That gives me my 6 oxygens. However, now I've got 2 potassiums and 2 nitrates. Well, my nitrogens, nitrogen, so I've got 2 nitrogens because I've got 2 nitrogens here. So my nitrogens are fine, but my potassiums are not. I've got 2 potassium here, so I need to put 2 potassium here. And that's it. That is everything balanced. So hopefully you know what one more thing. So basically this, guys, it's in a solution. So the state symbol for this, whether it's a solid, liquid, gas or aqueous solution, is this is going to be aqueous. If anything is mixed in a solution, guys and girls, it's aqueous. So your sugar in your tea is an aqueous solution because it's a mixture. This again is a mixture, it's a solution, so therefore this is going to be aqueous as well. This one is our precipitate, as we said, it forms a yellow precipitate, so our precipitate is always solid. And this one as well is not a precipitate, this one is able to dissolve in the solution, and so something that's dissolved in a solution is aqueous by its nature. Thank you very much. So now we're going to look at uses of precipitate, okay, because they do have uses, and the specific use that we're going to be looking at is barium sulfate. Right, so let's have a look. Barium sulfate, right, and this is called aka barium meal, okay, so aka barium meal. And the idea behind this is that people will drink this. Right, so they're gonna drink this thing, and it will show up in your digestive system. It will show up in your digestive system. And as a result, you can take X-ray images, if that makes sense. So number one, what we got to realize is this is a solid precipitate, right? And number two, what you got to realize is that this is insoluble. So why is that a good thing? Because it will not be able to, it will not be absorbed by the blood. Because you don't want it to be absorbed by the blood, you want it to go straight through your digestive system, so you can highlight problems within the digestive system by x-rays. And finally, this is non-toxic, so that's always a positive thing when something is not toxic. And so because of these three things, it's very safe to swallow the barium meals. Okay, and so that concludes precipitates and solubility. I'll see you on the other side.